Good morning to all of you. Good morning and welcome. So we are discussing about plate tectonics. First of all, I am extremely sorry for delay. There's some technical problem. Well, we are discussing about the theory of plate tectonics, and I hope all of you have studied and all of you must have seen that the theory of plate tectonics you must have studied. So one thing here, how the theory of plate tectonics is an improvement over the continental drift. See, the theme is same. In case of continental drift theory, it was basically about drifting of the continent, and here you are talking about instead of continent, plate, right? So plate, these are nothing but a huge lithospheric slab above the asthenosphere, which are moving in different direction based on the available convection current from mantle, right? So instead of continent, it is a plate. Second point is how it is an improvement over this. Mechanism of plate movement, whatever given in the theory of continental drift, was completely wrong. Okay, but here the mechanism of the plate tectonics, what it was, it is completely wrong, as I said. In this case, it is different here. In case of plate tectonics theory, in case of the theory of plate tectonics, what is there? In case of the theory of plate tectonics, it is not the mechanism is explained here in terms of what? The mechanism is explained in terms of the convection current, thermal convection, or whatever may be the factors, whatever he has given. So gravity is what? Because of the one plate subducted with another plate, gravity, the major cause there also. This is also indirectly helping the plate movement. So all these things scientifically explained in the theory of plate tectonics. Okay. So another things, you know, how it is an improvement over this, about the explanation of, they are in the continental drift said that in the continental drift theory, it was said that the continents at the western margin you have the mountains, fold mountains. Now this theory of plate tectonics is giving a reasoned account why these mountains are present in different region, all the fold mountain, volcanic region, earthquake zone, etc., etc. Okay, so you have like whether it is block mountain, fold mountain, volcanic mountain, whatever is there, why it is, how it developed, reasoned account is given by the theory of plate tectonics. It is really an improvement over this. Okay, so you can think about this, do study on that. Let us now move on to a topic today. It's about earthquake, which I'll discuss. I'll discuss about the earthquake today. What do you mean by earthquake? What is an earthquake? So today we will look at earthquake and volcanism. What is an earthquake? Okay. So earthquake is what? A tremor which you feel over the earth's surface, the vibration over the earth crust, motion of the ground surface, a motion on the ground surface, a motion on the ground surface ranging from a faint tremor to a wild motion, ranging from a faint tremor to you have to wild motion capable of shaking the entire building. Building and major structures over the earth's surface, over the earth's surface. A motion on the ground surface ranging from a faint tremor to wild motion capable of shaking the building and major structures over the earth's surface. This is what is called as the earthquake, as you know. If I'll go for this in detail, like the earthquake, scientifically speaking, the earthquake is nothing but the sudden release of the stressed energy from the earth's interior. Okay. So, let me talk about this RF Reid, HF Reid in his elastic rebound theory. HF Reid, REID, in his elastic rebound theory said that earthquake is the vibration of the earth's crust or earth's surface due to the sudden release of the stressed energy from earth's interior. HF Reid, he said in his elastic rebound theory on earthquake, he said this thing, that earthquake is the vibration, shaking of the ground, okay, vibration of the earth crust or the surface due to the sudden release of the stressed energy from the earth's interior, okay, from the earth's interior. When the rock strata is beyond the carrying capacity of stress, they release this. Okay, can you note down this point, please? Earthquake is according to elastic rebound theory of HF Reid. I am just giving this with a scientific tenor. You need to explain it. That's why I have given. Reid's elastic rebound theory is a very acceptable one in the causes of earthquake. Why it is he has given also. Though according to HF Reid's elastic rebound theory, earthquake is the vibration. It is the vibration of the earth crust or the surface due to the sudden release of the stressed energy from the earth interior. Okay. Why there is release of stressed energy? Release of the stressed energy, from the earth's interior, release of the stressed energy from the earth's interior is due to endogenetic disturbances and continuous accumulation of stress energy okay, release of the stressed energy from the Earth's interior is due to the endogenetic disturbances and continuous accumulation of stressed energy. When the rock strata cannot hold more stress due to attainment of its optimum carrying capacity or limit, it releases these energy in the form of primary P and secondary S wave. Again, please look at here. Let me explain it to you. Release of the stressed energy from the Earth's interior is due to endogenetic disturbances. Endogenetic disturbances mean Earth, inside the Earth there are disturbances. Whether the plate movement because of convection current, or due to cooling of a particular region, or due to any of the imbalances inside. So, release of the stressed energy from the Earth's interior is due to endogenetic disturbances and continuous accumulation of the stress energy. धीरे धीरे करके stress energy, जो stress क्या होता है, मैं अगर ये देखिए, if this is a let us say one stick, okay, I'll give pressure like this. There is a stress here. ये stress होगा यहाँ पे. I'll give more and more pressure now. It will crack. होगा कि नहीं? So the stress energy, stress into strain or maximum stress or strain, then subsequently it will release the energy. ये टूट जाएगा. It will have a cracking sound also. So the stress energy released into here, sound energy here. So energy cannot be created nor be destroyed. It only changes from one form to another form. You know it. Now what happened here? ये जो स्ट्रेस एनर्जी था वो रिलीज हो जाएगा इन टर्म्स ऑफ प्राइमरी एंड सेकेंडरी वेव हियर. व्हेन द रॉक स्ट्रेटा कैन नॉट होल्ड मोर स्ट्रेस ड्यू टू अटेनमेंट ऑफ इट्स ऑप्टिमम कैरिंग कैपेसिटी. कोई भी रॉक स्ट्रेटा का किसी का भी एक ऑप्टिमम लिमिट अप टू व्हिच इट कैन होल्ड द स्ट्रेस. इफ इट इज बियॉन्ड दिस, it releases this energy in the form of primary and secondary wave. Okay. Okay, whenever it attains the carrying capacity, see, everyday convection current in the mantle is going on, yes, enough to shake the fragmented plates in the lithosphere, yes. If so, is not the earthquake happening every moment on the earth? It is happening. It is happening. In most part of the earth, it is happening. Earthquake is going on, continuous phenomena. But one thing you remember here, major earthquake will have like carrying capacity. There is a carrying capacity of the rock strata also. Rock strata ka carrying capacity, it will absorb the stress for long time. For some time, it will absorb the stress. Whenever it is beyond its capacity, it release the energy. Okay, whenever it is beyond the इसलिए मैंने कहा stress due to the attainment of the optimum carrying capacity, optimum limit, it release this energy in the form of primary or secondary wave. They are called as the earthquake waves, primary wave and secondary wave, P and S wave. Is it clear to you? Is it clear? The place of attainment of the maximum stress to no stress, that is release of the energy, is known as origin of the earthquake, place of origin of the earthquake, which is called as the focus. Again I am saying, I hope you have written this. Is it clear? ये clear हुआ कि नहीं तो repeat करूँगा. Have you got this? Yes. Done. Let me now move on. फिर देखिए what happened here, as I just said, carrying capacity limit, it released this energy in the form of primary and secondary wave. Now what happened, the place of release of these energy in the form of waves is called as focus or hypocenter. Focus or hypocenter. Hypocenter. Focus or the hypocenter. Okay. The place where this release of energy takes place, that is the place of origin of the earthquake. It means what? The place of origin of the release of this energy mean place of what? Origin of the earthquake. Origin of the earthquake is called as the focus or hypocenter. Focus or the hypocenter. Okay. Now the places vertically above this is called as epicenter. Okay. Vertically above the focus on the Earth's surface, epicenter located. Epicenter. Epicenter is located. My friend, the question is, what do we mean by this endogenetic disturbances? What do you mean by this endogenetic disturbances? Endogenetic disturbances होता क्या है? Earth inside, I told you, mantle is very dynamic one. Mantle is the most dynamic layer, you know it. Now look at here. In this case, epicenter is above this. ये पूरा surface को दिखाए epicenter. In this diagram, epicenter is here, but focus is this side. This is the focus here. This will be the focus here. Above, because it is like the earth surface crossed is very in the upper part. This is focus and epicenter. This is epicenter here. This is focus here. This one S wave shadow zone, I hope you know it. S wave, P wave shadow zone. You remember that? Now the place of origin is focus and a vertical above is a epicenter, I said, inside the earth. So I told you earlier, mantle is very dynamic one. Earth's mantle is very dynamic. You remember that? Earth's mantle is very dynamic, and this dynamic earth surface, this very dynamic earth surface, what is happening here in this dynamic earth surface? The dynamic earth surface, this is like mantle particularly, somewhere you have, there are different composition you have, somewhere it is cooling very fast than the other nearby regions. Okay, because इसका composition समान नहीं है ना चारों तरफ. Somewhere you have more radioactive material, somewhere you have less radioactive material. So जब ये while it squeeze, stress will be different at different part. And different region में जहाँ पे stress accumulation ज़्यादा हो गए, wherever more stress accumulation, and if the stress is more than the carrying capacity of that rock strata, तो ये क्या होगा? Crack कर जाएगा और release of the energy होंगे. that is what is the release of the energy is primary secondary wave में. Rock as such, every product, every material, they have some elastic limit, you know it. So rocks also absorb it. ये रेड्स का जो थ्योरी मैंने कहा, रेड्स थ्योरी, रेड्स का रेड थ्योरी is very very important, which I have just mentioned about this. The theory of Biret, this particular theory, HF Red's elastic rebound theory, it says about this. It is practically studied many cases and found every rock strata has some elastic limit. Okay. Why some part of the earth surface is more earthquake prone than other part? Carrying capacity में बहुत कुछ है. आप एक चीज बताते हैं, my friends, some of you must have some experiences during your childhood that some of you, कुछ लोगों का तो होगा ना, हाथ पैर टूटा होगा, hand let us say, किस लोगों का हाथ तो टूटा, I mean fractured हुआ था क्या? You think about that. If you have fractured hand earlier, now you carry 2 buckets of water, 20 liter each. Okay, इधर ये है left hand and right hand both, bucket of water, 2 buckets of water you now you carry. If my right hand was broken earlier, अभी ठीक है, but if I'll carry for 5 or 10 minutes, I'll see first pain कहाँ होगा? In my broken right hand. Earlier it was broken right hand. Now we have stress here more. Carrying capacity of this fractured bone, now it is jointed of course, this bone is less than this unbroken one. होता है ना? Have you ever experienced this? Likewise, if you have a fault line, that fault line will generally cannot carry more stress. So that's why repeatedly you will have earthquake in that region. Fault lines of जहाँ पे crack है, जहाँ पे fault line है, वहाँ पे जल्दी earthquake होता है, क्योंकि it cannot store energy for long time. My friends, this is where mental which I have said, mental में नहीं है, focus is not in the mental, you remember. Focus mental में नहीं है. Some of you are asking, sir, focus mental में नहीं है. देखो यहाँ, you draw this is the focus and this is the epicenter. You first remember this. Focus or hypocenter is here. Hypocenter. Vertically above this is this one. Now, from here in different direction, okay, now let us say like this. Earthquake will go in this way. This is, here is the, as you know, epicenter or the focus. Here it is. Yeah. This is in the crossed only you have. This is crossed. This is mantle. This one is the core. Generally, most of the focuses are in the crossed itself. I'll tell you, based on the focus we have lot of variety of earthquake also. You got it here? Place of origin of the earthquake. Now it is clear to all of you. Clear hai? Now I will move on to, as I said about the earthquake, the release of the, when this stressed energy travel through the rock strata, there is shaking of the ground. Okay? When this stress energies travel through the rock strata, when these stressed energy travel through the rock strata, shaking of the ground takes place, called as earthquake. Now it is clear, I hope, to all of you. Here is a question: why epicenter is more destructive than the fault line? Because epicenter is the shortest distance you see vertically above this. And let me tell you, fault line, this is a linear part which is there. They also develop due to earthquake. Earthquake से fault line develop होता है. I hope you knew. Look at here. See here what happened because of earthquake. ये देखो. You see. Papua New Guinea in which earthquake was there. This is breaking of the entire crust itself. Road कैसे break कर रहा है. This is faulting because of the earthquake. Cracks developed due to earthquake. Isn't it? Earthquake, due to this you have crack development of the cracks. See here how it is. In this case, such a linear vertical crack developed because of this earthquake, as if somebody is tearing this like. This is displacement of the rock strata, and see what is a gorge like, such a huge deep profile it formed because of this, right? So earthquake generally occur because of the release of the stressed energy, and subsequently the stressed energy travel through the rock strata, and due to which vibration or shaking of these takes place, and you have the earthquake. Okay, I hope it is clear now to all of you. Earthquake is there, isn't it? So elastic rebound theory talked about the what? Elastic rebound theory talked about the development of earthquake because of accumulation of stress. Every rock strata has elastic limit. So after release of energy, they try to in fact come to the same position, and the rock strata will try to. Elastic में क्या होता है? Same position attainment के लिए कोशिश करेगा कोई भी object हो. So here also this will happen. Crack develop because of this differential movement. Cracks will be developed here in this case. Right? These are certain things scientifically I have explained it how it is. Now let me go to the causes of the earthquake. The place of origin of the earthquake is known as focus or the hypocenter, and vertically above this is epicenter, I told you. Okay, some terminologies with this, मैंने कहा place of exact spot underneath the earth surface at which an earthquake originates is known as focus. Let me clarify some term. Fundamental terms, terminology on earthquake. Many a time we people face problems. So आप लोगों के मन में होगा ना ये, कुछ लोग पूछने लगा है सर फोकस क्या है. I hope you got what is focus. मैंने कहा focus is what? Exact spot of the origin of the earthquake. Exact spot of the origin of the earthquake. Focus. Epicenter क्या है? Epicenter. Epicenter, what is that? You are asking what is the significance of epicenter? You stay there during an earthquake, you will enjoy. The place vertically above the focus on the surface. The place or point located vertically above the focus is called as focus on the surface, on the earth surface, on the earth's outer surface is called as epicenter. What is the significance of this? Epicenter will have the maximum destruction because of nearness. It is vertically above, means shortest distance it has, shortest distance. What are isosysmal line? Isosysmal line. Can anyone tell me what are isosysmal line? Iso mean equal. Isosysmal line. Can anyone tell me? Isocyst also it is called as isocyst or isosysmal line. Can anyone tell me on this? Isosysmal line. The line, here it is, isosysmal line is the line joining all points at which the intensity of earthquake is same. Line joining all points where intensity of earthquake is same or is equal. Okay, isocyst or isosysmal line. Now I have used the term intensity. Intensity of earthquake. Intensity of earthquake. Isosysmal. Now another one intensity hai, another one is intensity, another one is magnitude. Okay, magnitude. What is that magnitude? We will see later on. पहले देखते हैं another point. Mostly we are using the term here like homosysmal line. Homosysmal line. Many students have problem on this. Homosysmal line क्या है? कोशिस्मल भी कहते हैं. कोशिस्मल. Homeocyst or homeocyst also called as कोशिस्मल or homeocyst. What is that? homosysmal line or homeocyst travel path है ना, equal time at that time. So these are the line joining places with or where the shock arrives at the same time. Line joining the places where shock wave arrived at the same time. That is the same time of earthquake. Earthquake wave travel at the same time. This is like same time. Then it is line joining the places where shock wave arrived at the same time. This is, what is that? Homosysmal line. Homosysmal line or cosysmal or homocyst. This usually term we are using many time we are using this. Okay, I hope you got it. Two things here, और दो चीज है. During an earthquake, energy released, and during an earthquake, destruction is also there. The amount of energy released is not always proportionate to the extent of the destruction, is not it? क्यों? Let us say there is an earthquake. In the earthquake, if the buildings in that region are buildings located in that region, let us say earthquake resistant building. So even if you have, earthquake is very severe, impact will be less. So these are like, two different things here. So we need to look at here. Earthquake measurement को चलते हैं. Let us look at the measurement of the earthquake. Okay, is it clear to all of you? These concepts are clear, I think, to you. These concepts are clear. Now, earthquake measurement. How we measure? Measurement of the earthquake with the help of what? Seismogram. Seismograph instrument is what? Seismograph, isn't it? So, as I said about the two types of, we have two major types of what you call wave we are having, primary and secondary wave. They are responsible. Okay. Intensity represents the amount of damage caused in a particular part. Okay. I hope there are two things here. I just want to earthquake how we measure. Please note down here. Instrument used for recording the earthquake or seismic shock is known as seismograph. Seismograph. Instrument used for recording the earthquake. Seismograph. Okay. The instrument used for recording of seismic shock. Or earthquake. It's called as seismograph. Seismograph. Okay. Finally, a record you will get after this, during an earthquake. What you used to do, when there is an earthquake, a free falling, if you have a something, if you have a paper here, let us say, and because of earthquake there is a recording here, you will have the different type of line you will get. If there is a piece of paper, you will keep it here and it is hanging like this, you will have like this type of readings here. This instrument is called as what? Seismograph. But the recorded piece of paper where we have recording is there known as seismogram. Seismogram is the paper on the sheet which you will get where it is recorded. It is known as seismogram. SEISMOGRAMS. Seismogram. It is the recorded sheet prepared by seismograph. Seismograph है इंस्ट्रूमेंट, सिस्मोग्राम है शीट जो पेपर जो मिला आपको फाइनली. ठीक है. सो here is a question, somebody saying, sir, focus located inside the earth, whereas epicenter located on the earth surface. Yes, yes, correct. So seismograph and seismogram, you've got it. Let me now move on to one more point. Many a times we feel like what are the earthquake intensity and intensity of the earthquake. Magnitude of earthquake represents the amount of energy released. Okay, but intensity of earthquake represents the extent of death and destruction due to an earthquake. So we have different scale for measurement of this. Okay, different scale we are having for this. Richter scale examples is Richter scale magnitude RICHTER, Richter scale. It measures the magnitude, earthquake magnitude. Mercalli scale measures the intensity of the earthquake. Roche-Forel scale intensity, ROSSI, Roche-Forel scale, FORREL. Roche-Forel scale is also for earthquake intensity. These are the three scale I told you. Magnitude of the earthquake, how much energy it released during the earthquake. Intensity represent what? Extent of death and destruction, though in many cases interchangeably in sometimes we use, but is not, technically speaking there is a difference here. Richter scale is open-ended scale here. Open-ended log scale. Log scale पता है ना, 1 2 4 16 like this. अच्छा 1 to 4 16 नहीं, अजय geometrical progression हुआ. तो यहाँ पे if I'll go for this in layman sense, आम आदमी की भाषा में बोलूँ 1 2 3 4 अगर ऐसे कुछ होता है, 1 2 is 10 times 1, 1 to 2 आता है, 2 is 10 times 1 and 3 is 10 times 2, which is equal to 10 into 10 times 1. You got it? The extent of energy release will be more here. I hope it is clear to you. So step by step if you will go, there is a progressive increase in the magnitude you have increase होता है destruction. It is an open-ended scale. Open-ended इसलिए कोई fixed limit है. Log scale है ये. Magnitude shows the amount of energy released due to an earthquake. Amount of energy released during the earthquake or due to an earthquake, and it's an open-ended scale. I said open-ended log scale. But in case of intensity, it is a closed-ended scale. Closed-ended scale. मतलब here there is no outer limit or this one. So here in case of this no outer limit, here you have fixed scale. Closed-ended means fixed scale. It is fixed limit scale. Fixed limit scale is this one. Mercalli भी और Roche-Forel भी fixed limit scale है. they are completely different here. Okay. As I said, Mercalli scale, here the graduated इंटेंसिटी जो है ना अलग अलग रहेंगे, जैसे मैंने कहा कि इट विल बी डिफरेंट हियर. एंड रिक्टर स्केल इज ओपन एंडेड. आई से रोसीफेरल स्केल इज लाइक catastrophic, disastrous, severe, like this. Here it is catastrophic, severe, disastrous. Let me do it here. One is Mercalli scale. 1, 2, 3 up to 10. Okay. After this we modified into another one is modified Mercalli scale. Where the limit goes from 1 to up to 12. ये 10 था, modified Mercalli scale में 12 हो गया. This is feeble, not perceptible. You cannot recognize this. Clearly not observable, perceptible, not observable, or not perceptible. Then you have feeble, likewise this is catastrophic. Destructive or catastrophic, here also very severely destructive. Severe destructive. Like this type of scaling was there earlier. Now we are not utilizing this. अब हम इसको यूज नहीं कर रहे हैं. We are now going for this modified Mercalli scale, जो कि थोड़ा बहुत अगर महसूस होता है, feeble, perceptible, then is like intensity, ये जो है ना धीरे धीरे बढ़ता जाएगा. The degree of destructiveness increases here if you go scale जब बढ़ेगा. So याद रखें, ये modified Mercalli scale is the based on this. The earthquake or the seismic zone map of India is based on the seismic zone map of India is based on what? Based on modified Mercalli scale. It is based on the modified Mercalli scale or MMS. The seismic zone map of India is based on the modified Mercalli scale. I hope you got it now. Okay. कितना डेथ हुआ, क्या destruction हुआ, how much death is there, how much destruction is there, to what extent there is a loss of property and life, everything is there scaled in this modified Mercalli scale. So for administrative purpose it is very very essential, but for geological research Richter scale is very important. For geological research Richter scale is very important. Got it? I hope you got it now. Let me now move on to the next scale, Roche-Forel scale. Roche-Forel scale. It is not very much in use. in India, but there is a scale here. Like it shows the severity of earthquake, severe, 3 grading है इस पे, severe, then you have another one is catastrophic, and disastrous. Disastrous. Three categories. Severe, catastrophic and disastrous. These 3 types you have in Roche-Forel scale. These are relative things, in fact, based on relative to what extent the loss of property and life is there, based on this we go. It is a qualitative one. To what extent it is there. Quantity is definitely quantitative themes also we need to look at, but mostly it is a qualitative one. Okay, कितना loss of property life हुआ, तो उस पे quantity मतलब not a fixed value, rather a qualitative norms also we need to look at. So this is very important. Roche-Forel scale, 3 type of scale I said. Measurement is there, right? Let us now move on to another one. What are the causes of earthquake? What are the causes of earthquake? Look at now. Causes of earthquake. Causes of earthquake. What are the factors responsible for the earthquake here? क्या ऐसे factor है? What are the factors responsible for the earthquake? Yes, first and most important thing, as you know, earthquake is due to causes of earthquake. It is first and most is tectonic earthquake, plate tectonics, है ना? पहले तो हम चलेंगे natural cause. First I'll go for natural factors. Here the points are like, one is plate tectonics. Plate tectonics. Movement of the plate, whether divergence, convergence or transform fault boundary. Any movement of the plate, divergence, convergence or transform fault. In all cases, earthquake will occur. There is earthquake will take place because of all this. किसी भी केसेस में earthquake होगा ही होगा. In all these 3. Any movement of the plate, divergence, convergence or transform fault, in all cases earthquake will occur. In all cases earthquake will occur. Whether it is divergence or convergence or even transform fault, किसी भी causes पे होगा earthquake होगा. First natural cause यही है, plate tectonics. फोल्डिंग हो, फॉल्टिंग हो, इस पे भी होगा. तो सेकंड पॉइंट इज वल्केनिक इरप्शन. Volcanic eruption. If there is volcanic eruption, you will have development of this volcanic eruption. Because of volcanic eruption, tremor you will have, that is also an earthquake, volcanic earthquake which is called a explosion of a volcano, tremor will be there. Faulting within the volcano, collapse of the volcanic part, explosion, collapse in the volcanic, in the interior part of a volcano. Explosion, collapse in the interior part of a volcano, or even there is faulting within the volcano, faulting within the volcano. If there is an explosion of volcano, you will have this explosion. Acidic volcano are more explosive than the basaltic one. Acidic volcano, if it is there, you have sudden explosion leads to pyroclastic material throw out to a greater height, and there is tremor here. This may leads to earthquake. Here I said explosion, collapse in the interior part of the volcano, faulting within the volcano, inside the volcano, faulting also there sometimes. All these factors in volcanic eruption you have. Volcanic earthquake. Okay. Now another point is, we have third point, folding. That is any crustal deformation. Sometime crustal deformation, that is faulting. Faulting is what? Cracking, breaking of the crust. Breaking of the earth's crust. Earth's crust. Even another point is dilatancy. Dilatancy. Swelling of the ground surface, Pre volcanic phenomena होता है ये. Crustal deformation, faulting, dilatancy. This is also, crustal deformation may also leads to this. Due to any cause there is faulting naturally. Swelling of the ground, we have earthquake because of this. We have also the fourth point here, another important point. We have in naturally, if you look at isostatic imbalances or adjustment, isostatic adjustment. And its impact. Isostatic adjustment and its impact. What is isostatic adjustment? See, iso matlab equal. Iso mean equal. Static mean position. Equal position, maintenance of equal position of different fragment or segment of the earth. Okay. Equal position, maintenance of the equal position of the earth's different surface layer. Now how it is that? Let us see here. This region is known as asthenosphere. Asthenosphere. On this asthenosphere, you have above this, you have the lithosphere. Here it is, lithosphere. You know, there is continuous erosion. Continuous erosion in due course of time may leads to transformation of this, let us say, into this type. ये जो मटेरियल यहाँ पे था, इरोड होके ये सभी मटेरियल इधर आ गया, इरोजन है कि सब मटेरियल इधर आ गया. Let us assume this material came here. Okay, so what happened because of this? Because of this type of characteristics, what happened here? ये 1 million years ago, this position, this is now or at present, this is position, this is the present position, present position. देखो, so what happened here? The material got subsequently deposited here. So isostatic balance ये बताता है everything is in a equal position like this. सब कुछ इक्वल है. Now one part here erode होके इधर जमा हो गया, erode होके इधर जमा हो गया, मतलब here pressure will be more pressure, it will sink down and this part will go up. So because of this, what will happen now? This part will go up, this part will sink down here. Pressure होगा कि नहीं? अरे everything is in a equal position and this is, I said, asthenosphere is greasy layer, gel like layer. Now one part moved upward because of this, another part will have sinking. So definitely you will have a stress energy here. यहाँ पे stress होगा, कहाँ पे? Here you have stress because of this. Because of this you will have stress in these regions, and this stress leads to, subsequently, this stress may leads to, you know, there will be earthquake because of this. This stress may leads to the earthquake here. Breaking of this and the earthquake wave may move from here. समझ में आया क्या? Have you got this, what I said? So because gradually, naturally it will happen. Sir, dilatancy in fact is a phenomena. In fact, it is not accepted by every geologist. Dilatancy is a phenomena. Somebody is asking what is dilatancy? Swelling of the ground. जैसे earthquake हुआ, volcanic eruption हो रहा है, उससे पहले क्या होता है? पूरा डोम जैसा फूल जाता है ये. Just of arch जैसे ना. Gradual swelling of the ground is there. This is dilatancy. Okay, from the magma below or whatever is there, there is swelling of the ground. Ground will swells up. This is dilatancy. This is the pre-volcanic phenomena, or maybe it may leads to faulting also. Dilatancy, swelling of the ground, swelling from below pressure leads to swelling up of the ground. Dilatancy. So here I am saying that nearly 1 million years ago, this was the position. Presently, itna position hai. This got eroded and that got deposited this side. So the material got deposited. So that's why it is sinking. Okay, sinking of this. ये ऊपर जा रहा है, नीचे जा रहा है. What will happen here? Stress will be there. Stress leads to even stress energy get released in terms of earthquake. This is a continuous phenomena. Isostatic imbalances, isostatic adjustment. Iso matlab equal, stasis means standing. There is a concept known as isostasis which reveals that every part of the earth surface was naturally in a balanced position. Okay, every part is in a balanced position. आइसोस्टेसिस समझ में आया कि नहीं? डू आई नीड टू रिपीट? ओके ओके, which one I have to repeat? Let me repeat both dilatancy and this one. Okay, कुछ लोगों में dilatancy में problem है. Let me see here. If this is the ground, right? This is the ground position. This is, let us say, stage 1. Okay, stage 1. After few years, what happened? This region got swelling up like this. Maybe something like mantle plume is there or whatever is there. And in this case, now this swelling took place, due to which there is possibility of even here there is faulting possibility also there. This is stage 2. After few couple of years, it look like this, dilatancy. I hope it is clear now. This is, here is dilatancy. Normal position. Now this is clear to all of you. Now do you need repeat of your isostasis? Erosion is gradual phenomenon, but earthquake is a sudden phenomenon. Kya? What to clarify here, man? Is it related? Erosion, don't talk about erosion here. Erosion is different. Why you are diverting the topic? Come to the earthquake. Come to this particular topic. Ask me on this. Erosion I will discuss later on. Erosion is a gradual phenomenon, no doubt. Earthquake, sudden shaking of the ground takes place because of the accumulation of the stress energy. Earthquake is sudden, definitely. Erosion gradually. Can you see this, like, in your area? This, see, every day there is erosion of soil is going on. Will you feel that? But gradually, after 1 million years or after 1 lakh year, you will see the differences. It's a gradual phenomena. So gradually, if you are asking in terms of this particular topic, अगर आप इसके ऊपर पूछ रहे हो तो erosion will be there, gradually it will eroded. Erosion is there here, deposition this side, erosion and deposition. This is what I shown. This is here we have deposition. Okay, this is gradual phenomena. So deposition okay, whenever there is beyond the carrying capacity, then only it है. How the upper part goes upward? I do not understand. Did you got the things, like as I said? Why it got upward? Because I said plume from below, mantle plume or something is there, or there are certain things. मैंने कहा ना यहाँ पे, पहले डोम बनाएगा, बाद में volcanic eruption may be there. Volcanic eruption can be possibility is there finally. Before pre-volcanic phenomena I told you. Before bursting of this crust, they swells up mostly. Okay, my dear, got it? Fine. So I have just explained these. Can folding behavior of the crust related to dilatancy? See, dilatancy is anywhere because of compression or tensional force if there is swelling. But generally we go for the internal disturbances, plume, mental plume, where it comes up, it has the dilatancy behavior. There are a lot of confusion regarding this particular concept of dilatancy given by some of the geologists, but dilatancy can be a term here, so I have just used it. You please remember that. Let me now move on to another topic here. This is like isostatic imbalances adjustment and its impact. Clear? Repeat of isostatic, that's what I want. See, iso matlab equal hai. Everything over the earth surface is in a equal position. Look at here. According to the principle of isostasy, everything is in a equal position. If this is asthenosphere, then it is saying a mountain, plateau, plain. Now remember this case. This is the asthenosphere here. Here you have the asthenosphere. Everything is in a balanced stage. Matlab, per unit area, if I will see here, per unit area, the pressure exerted per unit area here and pressure exerted per unit area here, okay. The pressure created by this one here and pressure which you will get here and the pressure you will get here is equal. If the pressure here it is like x, let us say it is here is x, then here also it is x. I mean, always you remember that is the called isostasy. Isostasy का मतलब iso मन equal, stasy mean standing, isostasy mean in equipoise, mean every part of the earth is in a balanced with each other, all parts, every relief features on the earth crust, on the earth surface is in a balanced position और बैलेंस स्टैंडिंग में है, पोजीशन में है. यहाँ पे जितना प्रेशर ये दे रहा है वहां भी सब कुछ समान है. मतलब दैट्स वाई ओशियन फ्लोर आर मोर डेंसर देन द कॉन्टिनेंट. यही मेजर कंसेप्ट, दिस कंसेप्ट आइसोस्टेसिस सेज दैट ओशियन फ्लोर, rock of the ocean floor are more denser, rocks of the continental part are less denser. Here you have less denser rock, here you have more denser rock. यहाँ का जो rocks है बहुत ज़्यादा denser होंगे और यहाँ का जो रॉक्स है ये कम डेंसिटी होगा. ये एक प्रिंसिपल है. दिस प्रिंसिपल, दिस वाज गिवन बाय कंसेप्ट गिवन बाय डॉटन, DUTTON, नॉट नीडेड टू रिमेंबर दैट. डॉटन नाम का एक जियोलॉजिस्ट ने पहली बार दिया ये बात कहा कि ओशियन फ्लोर का जो थिकनेस है, आपको पता है ओशियन फ्लोर थिकनेस वेरी लेस, बट द कॉन्टिनेंट पार्ट इज वेरी थिक, बट बोथ आर एग्जर्टिंग सेम प्रेशर. आप बोलेंगे सर पानी है ओशियन में, है ना, बट स्टिल यू नो इफ यू लुक एट द प्रेशर देयर इज, they are compensated and they are already, the rock type are denser, much denser here. Plateau, plain, if this is a mountain है, ये mountain है, ऐसे plateau हो सकता है, ऐसे plain हो सकता है, whatever they are. This is the mountain. This is a, let us say, this is, here is a plateau. Let it be draw it as a plateau. Okay. ऐसे होकर अगर कोई plateau अगर है, let me draw it as a plateau. Plateau, or yeah, even here it is a plane. Let us say it is a plane here, or let us say it is a ocean surface. This is ocean bed, ocean floor, ocean floor. अगर ये सब होता है ना, इट इज ए ओशियन फ्लोर, दिस इज ए प्लेन, दिस इज ए प्लेट्यू, कुछ भी हो सकता है. सभी का जो प्रेशर जो है ना समान होगा एस्थनोस्फीयर में. एस्थनोस्फीयर जो नीचे है ना उस पे समान प्रेशर सभी जगह होगा, एवरीवेयर. यहाँ पे पर यूनिट एरिया जितना होगा यहाँ पे तीनों जगह समान है. मतलब इसका डेंसिटी थोड़ा सा, ये डेंसिटी जो है ना, डेंसिटी ऑफ दिस रॉक्स इज डिफरेंट हियर. इट मीन्स यहाँ का जो रॉक होगा, यहाँ का जो रॉक होगा, ये सभी में ये बताता है क्या, इफ इट इज लाइक दिस, ये यहाँ पे प्रेशर दे रहा है, ये यहाँ पे प्रेशर दे रहा है. तो हियर ऑल्सो इज सेम, प्रेशर इज सेम हियर, प्रेशर इज सेम हियर. चारों जगह पे प्रेशर सेम होगा. मीन दिस इज ए माउंटेन, दिस इज ए प्लेट्यू, दिस इज ए प्लेन, दिस इज द ओशियन फ्लोर. एवरीवेयर सेम प्रेशर दे रहे हैं. मतलब रॉक जो है ना डेंसिटी विल वेरी. डेंसेस्ट रॉक इज दिस साइड, लाइटेस्ट वन इज दिस, लेस डेंसर रॉक, मोर डेंसर रॉक, मोस्ट डेंसेस्ट वन इज दिस, है ना. इस टाइप का जो, इसलिए तो वो सब प्रेशर में है. नाउ व्हाट हैपन, सब कुछ पोजीशन समान है. अभी क्या होगा, लेट अस सी नाउ आफ्टर फ्यू इयर्स. ऐसे पोजीशन में था, ये रीजन इरोड होके ऐसे आ गया. दिस रीजन गट, ये इतना मटेरियल था 1 मिलियन पहले, ये इरोड हो गया. इरोड होके प्रेजेंटली दिस प्रेशर, दिस प्रेजेंट पोजीशन इज लाइक दिस हियर. सो हियर इट विल गोज डाउन, हियर इट विल गो अप. So the density of rock does not impact press on the what are you saying man? Density कैसे प्रेशर नहीं होगा एस्थनोस्फीयर में. Density of rock is there. You study first isostasy, एक बार पढ़ लो. And गूगल से पढ़ लेना, गूगल में सर्च करना. व्हाट इज इट इज नॉट इम्पोर्टेंट फॉर जीएस, एंड आइसोस्टेसी कंसेप्ट इज नॉट इम्पोर्टेंट फॉर जीएस. रिमेंबर इट इज ए फैक्टर फॉर अर्थक्वेक, सो आई हैव जस्ट गिवन. ओके, isostatic imbalances, don't go in detail of this, but one thing you remember, there is a natural balancing mechanism of the earth itself. Everything over the earth surface is in a equal position. अरे तराजू देखा है, वेइंग मशीन देखा है, तराजू है, आज लेके देखो यार. एवरीथिंग इज इन ए पोजिशन लाइक इक्वल पोजिशन. इफ एवरीथिंग इज इन ए पोजिशन, इक्वल पोजिशन, आई विल कीप सम मोर मटेरियल हियर, इट विल सिंक डाउन, so it will have stress here. Same thing, because of erosion from this side, either here deposition is there, deposition is more this side, erosion is here, ये erosion हुआ, यहाँ पे deposition हो गया. So because of this, what happen, here वजन बढ़ जाएगा, here weight will be more, here it will be less. So ये ऊपर जाएगा, ये नीचे जाएगा, तो क्या होगा, यहाँ पे स्ट्रेस होगा. सीधी बात है, डायरेक्टली इट इज रिलेटेड. देयर इज नो point of confusion here. Tell me now again if you haven't got. These are very simple things, very simple thing these. ये बहुत ही सिंपल है. एक पहाड़ी लेटर से ऐसे था, ये जो ब्राउन में मैं दिया हूं ये देखो, राइट, और हम मानते हैं ये पूरी तरह से बैलेंस पोजीशन में, ये पहाड़ी है, ये रिवर देखो, ये माउंटेन, और ये माउंटेन हियर, दिस साइड लेट अस से यू हैव योर व्हाट इज दैट ओशियन, ये इरोड यहाँ तक ओजन ये हाइट था, ये इरोड होके चला गया इधर। Here you have more pressure because of this. Now it will have more pressure. It will give more pressure. This part will go up. This will goes down. So you have this because of this. What happened? Here you have imbalances. Did we disturb the isostatic balance in large metro? Yes, yes. Of course, it is there. That is what is the earthquake you are having now. By large dams were now restricted. Why? Because of this cause. Tehri Dam project, why it was challenged. Okay, let me now come to anthropogenic causes. Anthropogenic causes. Let us now move on to anthropogenic cause. Anthropogenic factors will go for now. Second category of factor. First is natural factor, anthropogenic. Anthropogenic factors. In the anthropogenic factor, the first one is, as I said, isostatic imbalance. As you, some of you are saying, did we disturb the isostatic balance in large metropolitan city? Yes. That is what? First one is construction of large dam and consequent isostatic disturbances and consequent isostatic disturbances. Leads to the reservoir induced earthquake. Example दो, कोयना earthquake. Koyana in India, Koyana Maharashtra या Karnataka, where it is. Koyana earthquake is the best example. Koyana earthquake is the best example. Best example is the Koyana earthquake. Koyana earthquake. Koyana earthquake. Is my handwriting is okay? और अभी भी तुम डॉक्टर बोल रहे हो, मेडिकल साइंस डॉक्टर ऐसा तो नहीं है? ओ हेलो, टेल मी, इट्स इज इट ओके, एलिजिबल है ना? Construction of the large dams and consequent isostatic disturbances leads to the reservoir induced earthquake. Example, Koyana earthquake. Hoover Dam earthquake. Hoover Dam, where it is? Hoover Dam. Hoover Dam earthquake, where it is? Hoover Dam earthquake in USA. Koyana earthquake in India. We have some of the earthquake here, you know, Hoover Dam earthquake की वजह से, Koyana earthquake in India, or even Cobora Bassa earthquake. Cobora Bassa earthquake, where it is? Zambezi River. Do you know about this river? Zambezi River. Earthquake at करीबा डैम, करीबा डैम, कोबरोबोस्सा बोलते हैं, कोबरोबोस्सा अर्थक्वेक है, कोबोराबोस्सा अर्थक्वेक, Zambezi river valley in Africa. These are like, some of the most important well-known cases I have just given. Earthquake is due to this. This is a very good example. I hope you will be able to cite these things also. And reservoir induced earthquake. That is the cause. If there is a reservoir, if you will construct at the plate margin, like in the Himalayan case, Tehri Dam, why you are opposing that one? Tehri Dam earthquake. Can anyone tell me Tehri Dam is located on which river? Anyone? Tehri Dam is located on which river? Anyone? Tehri is located on which river? We are opposing the Tehri Dam because of this particular one cause is here, there is possibility of, because as it is, as some of you are asking why you have more and more earthquake in Himalaya. Some of you are asking how Nepal is different from India. Nepal is located on Nepal is a Himalayan state. And Himalaya is in the seismically active area because the Indo-Australian and the Eurasian plate are meeting there, and because of folding it developed. That is the cause. Satluj, you are wrong. कोई तो सही बताओ यार. I am here asking to enter you. भागीरथी, wrong. भागीरथी, कैसे होगा भागीरथी? तेहरी डैम, Satluj, Bhagirathi, no? Dekha, we have studied so many times Tehri Dam, but see, this is what is the precision required, while you are studying. And believe me, while I will discuss about geography of India, I am sure you feel, I have seen many times, students like, sir, we don't know this much. These are the so basic things. ब्रह्मपुत्र, hey, तुम तो पूरा ज्योग्राफी चेंज कर दिया. ब्रह्मपुत्र, ब्यास, सतलुज, नो, टेल मी, गंगा, देखा, not a single person has given me the right answer here, not a single yet. This is not good. I have a lot of expectation from you. I do expect, that at least the basic things, Mandakini, no? I know that while you will search even in Google, you will not get it properly, that's why. Yes, I want the exact river. Bhagirathi we used to call, but I want the exact. Here two river meets, in fact, in that region it is. Two river where it meets. दो नदी मीट करते हैं वहां पे, मिलता है वहां पे है. बताओ अब, which is that river? It's here. Look at here. For your information, I am giving you. This is a river. This is another river. Both are meeting here. This is river. This is Devprayag, right? Place is Devprayag. Devprayag. No. Bhagirathi and Alaknanda, no. If this is Devprayag, one is which river and two is which river? Okay, I don't want to spend more time on this, but you remember, one is Bhagirathi, one is Alaknanda, no doubt here. Now you tell me, another river is draining to this particular point. एक river यहाँ आके meet करता है. ये नदी का नाम क्या है? Very good, very good. Somebody has said Vilangana and Bhagirathi. Thank you very much. Thank you. One person finally found out. Thank you very much. Vilangana and Bhagirathi. Here you have the Tehri Dam. Tehri. ओके विल से सर ये तो भागीरथी है तो भागीरथी होगा, है ना. भागीरथी बिलंगना रिवर. दिस इज तेहरी डैम. ओके वी विल डू दैट, आगे करेंगे. So these are certain things. That's why Tehri Dam project was stalled. Because of that, we said like it will have a lot of impact on this. Bilangana and Bhagirathi. बिल्कुल सही बोला आपने. Thank you. So likewise, you have so many things. Many a times we don't look at properly, so we missed out, isn't it? So आप करिए. Clear? Okay. So collapse. This is here is one causes here. Anthropogenic cause in which first construction of large dam, that is the reservoir induced earthquake, I said. Second point we will see now. Second point. According to WBPSC, it is Bhagirathi. Because Bhagirathi, the option was not given, then Bilangana must not have given. Then it will Bhagirathi, definitely. Someone is saying, according to WBPSC, it is Bhagirathi. Yes. Bhagirathi, why? Because Bilangana is not given, because there is a meeting place. That's why Bhagirathi must have written. Okay. So that may be the cause. So, at the meeting place of this, on the Bhagirathi, on the meeting place of this river. My question is on the meeting place. Okay, thank you. Bhagirathi and Bilangana, they meets here, right? Fine. Let us now move on again. What are the other factors? Tell me. क्या हो सकता है? Mining, deep bore mining, and cavitation. This leads to this third point. Mining and cavitation is there. Nuclear explosion, bombing. This is also a cause. Nuclear explosion, bombing. Nuclear explosion, bombing. Mining and cavitation. Then you have large scale depletion of groundwater and development of void space. This is also a cause. Delhi, we have problem of there is possibility of earthquake. We have already earthquake was there in these regions because of this. Let me see if it is there. Earthquake in Delhi. देखो ये. Here, groundwater role in the Delhi tremor. This was in the news. Groundwater role in the Delhi tremor. क्या था ये causes, why it happened? Role of groundwater in Delhi tremor, है ना? Look at here. rapid groundwater rapid groundwater, देखो यहाँ दिया है, पेपर में आया था ना, दिस वाज इन द न्यूज पेपर, आई एम जस्ट गिविंग यू फ्रॉम द न्यूज पेपर इटसेल्फ. Groundwater role in Delhi tremors. The alarming frequent earthquake in Delhi NCR last year may have been the result of rapid groundwater extraction in the region, largely occurring in the 25 km of surface, and relation that has been found between the withdrawal of water. Withdrawal of water. More if you withdraw water from this groundwater table, Vadose zone creates होता है, Vadose zone. Okay, this is a possibility of, there is a possibility of earthquake because of this also. Vadose zone creation is also a cause of. This is a very good example. The most important burning thing, this is like, in the cities areas, in some of the important cities in the world, you have this void space creation and sinking of this. My friend, one very good question somebody has asked me. Sir, the states belongs towards the Himalaya zone is the earthquake prone zone. Yes. But the southern states of India do not experience earthquake. Yes, in general. But there are fault line. There are fault line. Bhima fault is there. Godavari fault is there. Kaveri fault is there. Faulting there are. In India part we will discuss. There are fault lines. Also we have in Western Ghats. Western Ghat is formed because of what you know? Upwarping. ये कुछ एरिया जो है ना, in the Indian mainland area, the part of southern India का एरिया ऊपर ये नीचे चला गया. Which one? Part of this, दो Arabian Sea के अंदर है ना, it was submerged inside because of faulting. ये नीचे चला गया है. Entire landmass, ये जो जमीन है नीचे हो गया है इसे. And this leads to formation. That's why Arabian Sea has a huge area of continental shelf. यही तो cause है. So there is disturbances. Who said there is no disturbances? Comparatively it is stable, but stress जो है ना accumulation ज़्यादा होता है. My friends, एक चीज देखो. Always everywhere stress and strain is there. No place over the earth surface is free from earthquake. Remember one thing, no place is free from earthquake, but yes, some regions they can absorb the stress energy and release them after a long time period. Have you ever seen your friends? आपका friends में देखा होगा कुछ लोग गुस्सा नहीं होता है, they are not angry. Some people they get angry frequently. The person who is not angry frequently, or who is like, cool person, whenever the cool person get angry, usually very destructive at that time. देखा है जब गुस्सा में होता है, शांत जो लोग हैं बहुत गुस्सा, मतलब you cannot control them. Why it is? Likewise, earthquake, the stress wave got absorbed, but when it released, very devastating. Okay, so this is where I'll come to that one. What are the processes on this? But there is fault line because of which you have earthquake in Kerala, in some part of India, in southern peninsula. Though it is a stable land. Yes, very good question you asked. Thank you. Now, as I said about the earthquake here, causes you got it. Now let us look at types of earthquake. How many types of earthquake you have? Types of earthquake. Types of earthquake. Okay. Types of earthquake. How many types of earthquake you have? Do you have any idea how many types of earthquake? Based on the focus, you have shallow focus earthquake, medium focus earthquake, and deep focus earthquake. One is shallow focus earthquake. Shallow focus earthquake. My friends, shallow focus earthquake where the focus is located somewhere nearly 70, 45 to 70 kilometer depth, up to 70 kilometer depth, maximum not 70, 30, 40, 45 kilometer, up to, there is no standard thing for this, mile wise if it is 30 mile nearly, 30 miles depth, focus is up to 30 miles depth, 30 mile है, 30 mile, kilometer में how much it will be, 30 miles depth. If you go for intermediate focus earthquake, intermediate focus earthquake, intermediate focus earthquake in which intermediate focus I said intermediate, so it is somewhere 30 to 150 150 miles depth, focus equal to 130 to 30 to 120 150 miles depth. And another one is deep focus earthquake, third one is deep focus, deep focus earthquake. Some geographer may vary in there, but geologist will have the same. मैं जो बोल रहा हूँ ये category as per the geologist. Some geographers has given ऊपर नीचे थोड़ा बहुत up and down they have given the values. 150 to 450, 150 to 450 miles. Focus is front, focus presence is at, focus is at a depth of 150 to 450 miles. Right? Deep focus earthquake. Three types of earthquake. Shallow focus, intermediate focus and deep focus, three type of earthquake you have. Based on the depth of the focus you have this type of earthquake. Okay. Now, earthquake if you look at in different region, earthquake you will find in different part of the world, distribution if you will see in different region. Three types of earthquake I said. Now one question here, Aravalli mountain was happened, isostatic adjustment earthquake. Yes, yes it is true, absolutely correct. Sir, since the transform movement is conservative in nature, can it cause a massive earthquake? Yes, of course. There L wave, surface wave is very, very active in that, very destructive. Or it is just limited to mild earthquake. No. In case of conservative one, this is like the focus is at the upper part. जब फोकस ऊपर सरफेस में होता है, shallow focus earthquake है, very destructive it was. Most of the shallow focus earthquake you will get, shallow to intermediate focus you will get where? In case of transform fault. That's why. So, plate causes of earthquake or the position of the focus also shows, the rate of destruction or destructiveness or power of the earthquake. Earthquake power कोई भी करता है, ठीक है. I hope you got it now. Let us now move on to distribution, world distribution, major earthquake belt of the world. Major earthquake belts of the world. Major earthquake belts of the world. What are the major earthquake belts of the world? We will see. Major earthquake belts of the world. What are the major earthquake belts of the world? My friends, there are distinct belt where you have earthquake is more. The first and most important one is the circum-Pacific belt. I mean the area surrounding the Pacific Ocean, circum-Pacific belt, the area surrounding the Pacific Ocean. Because as you know, one side you have where one side convergence of the plate, another side you have divergence, another in near San Andreas fault line, if you remember, there is transform fault. There is convergence, divergence, or slide past each other. In any case, you have earthquake. So the entire region surrounding the Pacific Ocean, circum-Pacific belt, is the most active zone here first. Second region is Mid-Atlantic belt. At the middle part of the Atlantic Ocean, you have Mid-Atlantic belt is the second most important area. Mid-Atlantic belt, middle part of the Atlantic Ocean. Third one, we called it at East Indian belt. Indonesia, Andaman Nicobar, island of Burma. East Indian belt. East Indian belt. East Indian belt. East Indian belt. You know what is that? East Indian belt extend over Indonesia, Andaman Nicobar island and Burma. Andaman Nicobar, Myanmar, here it is Indonesia. My friends, I am giving this based on the Indian Geological Society. You know, in Indian geologists they have given this, okay, as a distinct major area recently, categorized as Indonesia, East Indian belt, they call it in the East Indian belt, okay. You please add this, that's why. Okay. Another one, Mid-Continental belt. I said Mid-Continental belt. Mid-Continental belt is from Mediterranean Sea, to the Himalayas. Mediterranean Sea to the Himalaya. This entire region, Mediterranean Sea to the Himalaya, this is a very, very important area. Mediterranean Sea to the Himalaya. Mid-Continental belt. Mediterranean Sea to the Himalaya, from Mediterranean Sea region up to from Afghanistan, Iran, West Asia also there, and these entire regions you have to Himalaya. Fifth one is you have East African belt. East African belt, it is eastern part of Africa, you know, eastern part of Africa. If you remember that faulted line, Africa की जो faulted line है, याद है आपको? I have already gave you this. If you remember, I have already discussed about this one earlier also, like in the plate tectonics, that here you have a fault line, here you have a fault line. You remember this? This is going in this way, this is in this way. ये faulted line जो है, this is East African belt. East African belt. Okay. Seychelles, Gulf of Aden, all these also there. Another one, interplate seismicity. Sixth one we can say interplate seismicity. Interplate seismicity mean wherever there is a fault line or a plate also we have seismic disturbances. Interplate seismicity. Interplate seismicity also there. Okay, you got it now? I got some question, let me answer it. Can heavy construction create earthquake in Dubai? See, there is a stress analysis before that, and based on that they are constructing building here, but definitely it will have an impact. So the pressure, how it will be well distributed through entire area, that's why building structure they are preparing. Why the foci of the earthquake is in the area of mid-oceanic ridge are at shallow depth, whereas along the Pacific rim they have a deep focus. Pacific rim they have deep focus. Pacific rim में जहाँ पे नीचे जा रहा है ना, wherever it is going deeper inside at around 700 kilometer, there is change in the state of matter and then earthquake is there. That's why convergent plate, divergence में shallow focus में होगा ही. Okay. Next question here. Sir, which one is more common, shallow, intermediate or deep? It is more common is shallow focus. Recently, new map of Earth's tectonic plate has been published. What is the significance of that? And also major difference from the older. Yes, thank you very much, man. Thank you very much for giving this information. Let me tell you, this particular thing, this particular the new map is talking about microtectonics in detail of this. So, fragmentation and recurving, refragmentation of the plates, this is what it has shown. Do one thing, send me that new map. In your group, you just send it, okay? Group में भेजो इसको in during the break, okay? If you have, please. If the Andaman and Nicobar Island are the extended part of Himalaya, then why this part is not included in mid-continental belt? It is included, but its frequency is more. So our Indian geologist particularly has taken up this as a new because of some very different extent of the earthquake. Here you will have, like, technically speaking, you have only surface, but there are three types. All the three types of earthquake you have. Both this is here is surface, deep focus as well as shallow focus or medium focus earthquake we have here. This is there is some uniqueness of this in terms of their stress and strain analysis. Okay, why can't we know earthquake before, please some mention? Yes, we will able to do this. Let us have the lunch break. After this we will look at how to predict the earthquake. Okay, how you can predict the earthquake, we'll see. What to repeat the last point, what I said, last point is interplate seismicity. It means what? कहीं पे भी microtectonic is there, दो प्लेट बन जाएगा, one plate. Fragmentation or two plates wherever they are joined with each other, there is. Okay, so these are the case. Thank you very much. See you then after the break. Let's have the lunch break at 2 p.m. we will meet again. Thank you. Do revise. Give me that map if you have or any problem. Please let us know. Thank you very much. Bye bye.